use a generic in that case. No, because God, this is it's like it's something I use frequently, but it's hard to describe exactly these use cases, like when you would describe or use things. There's a shared object that your objects you reason about, shared interface. You're interested in if you have logic, 5 different types of objects. It's a replacement for, you can think of generic as a replacement for overloading your method like 100 different times. Right? But it's different than a use class. So if you wanted to on all instances of this, you wouldn't use generic in that case. Generic is like a way to.
That makes sense.
It's a replacement for having like 5. But it just operates and alternatively, in that method, you don't like look at the instance to see what it is and like do different things based off of that. Then you can just use the base instance of the method, right? So you see what I'm saying there? Like if you accept like an object, for instance, it is the method parameter. And if in that method you're like, if it is a string, do this. If it's an int, do that. If it's a whatever, do whatever. That's a good candidate for making a generic, right? Or if you have like, you want to repeat the same lot, like you find yourself having written a method like 6 times with different parameters. You're like, well, I could just make this a generic and make this one method, right? That's a different use case for, I want to operate on all instances of maps, for instance. So it's a slightly different use case. So you wouldn't want to use a generic in that second use case. You're like, just give me a map object, and I'll work with that, right? So it's kind of a subtlety thing, right? There's no clear right or wrong answer. So again, just reiterating, instead of having a method overload for a bunch of different types, you have a generic that gives you the ability to just pass in an arbitrary type. Yeah. So check it out. You can add constraints to these guys, right? So you could say t extends number, which is what you saw Avery do the other day. So you can say that with this generic method here, we're adding the constraint where you pass in t, but t has to be inherit number. So if we look at number, the number-based class, if we go to its implementations, these are the things that derive from number, basically all number variables. We have integer, float, double, long, all that stuff, right?
The reason that you would use that is if like you have a double or an int or a float, right? So like you want to like protect against like what kind of number it is.
Yeah.
Okay.
So
you would use that like instead of
if we try to do this and we pass in a string, this would give us a compile time error.
I was thinking more like you would use that instead of like an int or a double specifically, or like a float specifically, because you want to use all 3 of them, or like you want to make
Yes,
you can
yes,
all 3 of them.
yes.
Okay. That's neat.
Show. So let's take a look at array lists. Just give me array lists. So just like we can have, like we made a generic method here, but you can also have generic classes. So we have public class array list E. So the name, like the convention for these generic names is one singular letter, by the way. And the lesson that I meant to go over today, but since today is kind of abbreviated, I kind of want to shove some of this for tomorrow, is actually here. So like this tutorial around generics is actually some of the best documentation for generics you'll find. It's from Oracle's website. So generic types, I think that, yeah. So when you see this E here, it usually stands for an element of a collection. K is key, N is number, T is type, V is value, so on and so forth. Yeah. So like if we want to look at how hash maps are implemented, so like array list of E stores internally that'll manage a field. So this is like really low-level Java stuff, but basically there's an object array that stores all the element data, right? Yeah. It'll convert back and forth to type E, though. Let's see. So if we do ArrayList.add, so we accept type E, so whatever we specified in our object as the thing we're adding. So ensure capacity, so elements, arrays can't change size. So like ensure capacity internal here has got to check the size, right? And so it just basically stores E in there if the size is valid, right? And then stores true or false whether or not it successfully added the thing. Actually, it just returns true. Yep. Well, if it's yeah, it'll throw an exception. Yeah. So that's how you add like a generic E value. Is that when you are designing your ArrayList class, you want to be able to support the addition of any type, right? That's how you do that. So if we look at hash maps, so if we think about like what hash map would look like from a public class standpoint, it would be public class hash map. And since it can store any type, it would probably be a generic, right? So what would like that look like? You think with that before we look at it, like what would you think it looks like?
I mean, you're storing elements, right? So it would be like hash map EE, but it could be.
Well, if you do EE, then the first and the second types have to be the same thing. So you're not just storing elements; you're storing keys and values actually. So it wouldn't be E.
So it wouldn't be E?
Nope. So if you look back at this page, there's internally the convention.
So it'll be K and E?
Yeah. So public class hash map KV is what we expect.
So KE?
KV.
Oh. And that's generic. Ah, duh.
So you have public class hash map KV. So hash map is a class that accepts any type K as a key and any type V as a V. It extends an abstract map. So there's an abstract map class here that accepts K and V. Abstract map gives you some things like size. They return the size of the entry set, right?
Go over abstract.
You mean abstract classes?
No, abstract map.
Well, we never really looked at this is the first time we've really been seeing abstract map.
Oh, I thought.
Well, we don't ever, well, since it's abstract map is an abstract class, we've never instantiated abstract map and used it. So we've used hash maps before. And now that we've understand generics, we can actually look at how generics are defined, or hash maps are defined. And I'm just showing you that they extend an abstract map class. Right. So I'm giving you the keys to analyze the source for Java. So you'll be able to get a further understanding of how these things work, right? So a hash map implements the map interface with these K and V generic variables, and also implements clonable and serializable. These two, basically don't worry about them for now.
So, and it implements clonable and serializable. What are those
No, these aren't keywords. These are interface names.
Okay, so how many is there? How many interface names are there? Too many to mention?
Yeah.
Okay.
Yep. There are some key ones like comparable and serializable is another big one. But an interface is the same commonality as a class, right?
Okay.
Like an interface is not like you don't just define interfaces in your system. You can define interfaces for the runtime of your application, which is totally awesome, right? So if you look at the definition of serializable, it basically just says, I mean, serializability of the class is enabled by the class implementing the serializable interface. Classes that do not implement this interface will not have their state deserialized.
Serialize, like to publish, right?
No, serialization means being able to turn an object into a string. So this interface doesn't actually have any methods that it requires its implementers to implement. It just marks it as serializable. There is no contract. Neither is there one for clonable. Huh. So if we look at Java lang object, so clone, there's a method on object called clone, which returns you a new object. So it throws a clone not supported exception if the object's interface does not support the clonable interface. So you can basically mark your object as clonable if you implement clonable, but it too has no method that it requires you to implement. It just marks it in the system as that. Right? So if we add a class here, it's like a people map. Hold on one sec, guys. Sorry. Hey, honey, what's up? I don't know. I've made a decision yet. It's going to be really difficult to get out of it. So. Honey, I know, honey. Can we talk about this? I'm in the middle of a lecture right now, so I'll call you back whenever I'm at a lecture, okay? Okay, thanks. So we have a protest planned for downtown Mooresville. They applied for a permit to protest at 7 o'clock tonight. And I have a crash course to deliver, so my wife is a little bit worried about that, considering we live a couple blocks away from Main Street.
Yeah.
So I don't think it's going to be like anything bad. I think it's going to be fine, but
Yeah, that was good.
yeah.
And the National Guard is here also.
Yeah. Anyway, so if I want to like extend hash map, I can just do public class people map extends hash map. Sorry. So I can specify that I extend hash map. I'm storing the hash map I'm storing is we're going to be storing strings as the keys and person as the values. So if I want to say like people map PM equals new people map, right? PM dot if I put it's going to accept key and string key and person value, right? That's pretty cool. So map is an interface, right? And when you design your code such that its dependencies are interfaces, like a variable name, a variable type is an interface instead of a concrete class, then if you want to change the implementation of that object, so like if I have a map interface, map supports like put and, well, let's look at map. Let's look at what map defines. So we have people map, hash map, implement map, hash map implements map. So anything that implements map says that it has a size method, an isEmpty method, and contains key method, and contains value, and it stores, it has get and put and remove. So these are basic operations that all maps do, right? So if you have an implementation of map, it has to implement all of these methods, right? That's how interfaces work, right? So if my variable type is a map and it's not a hash map, then the methods that I can use on that variable type are just the ones that are exposed by the map interface, right? So like if I have a map variable, all it knows is it's a map. So you can call map.get, map.put, map.remove, has key or contains key rather. And if there happens to be a method that exists on hash map, we wouldn't be able to use that method unless we casted our map as a hash map explicitly. Okay? Now, this is the kicker here. So if we did that, we're making a dependency between our code and the hash map code. Right? We're depending on the hash map to exist. If we just use a map, we localize that dependency to just where we assign that variable. So if we're like map kv people map equals new hash map string person, right? No, if we're like map string comma person people map equals new hash map, diamond syntax, right? Then if we know all we want to use is the basic map operations that any map gives us, then we can just have an instance of a math interface. And then down the road, if we're like, oh, we can't use hash maps anymore because we're in a threaded environment and hash maps are not thread safe, which means they can go into like race conditions and stuff like that. And we wanted to replace hash map with concurrent hash map, for instance, which is the thread safe version of hash maps. We could just be like, in that variable assignment, be like map kv people map equals new concurrent hash map. And then we are guaranteed, since our code was built upon the existence of a map, not a hash map, and a concurrent hash map also implements map, that our code still works, and we don't have to modify anything.
Can you go into the threaded part again? Because I'm not sure I understand it all.
Well, that's threading gets pretty deep. So that's not like, that was just an example of why you would want to replace a hash map object with another type of object. But like if you, in general, if you have a method and it works on an interface, right? Like say that it accepts, like we have a method that accepts an interface, right? So the only thing you know about a parameter when it gets passed into your method is that it implements that interface. So you can use that object's methods, the ones that the interface specifies, at your own discretion. You're like, okay, object, I know that you implement map. Let's use your put method. Let's use your add methods. Let's use your remove methods. And then you do your own thing. Like as long as you say you've implemented these methods, I'm fine. Just give me these values. How you do it, it's up to you. Right? So if you want to change, like when you pass it into it, like if you want to change the value of that, or the implementation, then you just change that object you pass in, right? And then you don't have to change any of your code. If your method accepts a specific, like if instead of accepting a map, if it accepts a hash map, then you make your dependency on the hash map class instead of the map interface. So if hash map no longer is good enough, you'd have to replace all of your code that references the hash map with the new type.
So by using interface, you have lower coupling, and using a hash map will create higher coupling.
Yes. Indeed. Yeah.
Coupling?
Yes. Coupling is a term that
I used that term like week 2, I think, maybe.
Yeah.
So how much more coffee? I'll be right back.
Your code, how much your code depends on other parts of your code. So what do you, so hash map is a specific type, right? And if you have in your code say we're going to use a map, and you just happen to say that it's a hash map here, okay? Because you said map down here, when you write out the code, any method that you use has to come from this, right? So if down the road you want to not use hash map anymore, maybe you use a different type of map, we'll call it different map. Different map might not have the method that hash map does. So you have to rewrite that line of code. And every time that happens throughout your entire code. Right? So if you put map here and then decide hash map, okay, then all you have to do to switch it, if you wanted to, is say different map. And then you know that once it plugs in a different map, it's not going to throw an exception because this also can use whatever it was.
Yeah.
You see what
Okay,
I'm saying?
yeah, I got it. So what's the coupling part?
Coupling is when code depends on other code.
Right. So the hash map would be dependent on.
Exactly.
Okay,
So the code that you're using here, this hash map, is dependent upon this code out here saying hash map, hash map. Right?
Okay.
So it's less dependent if it says map and then down here it says hash map.
Right.
Because they're kind of separated.
Got
It's
it.
not dependent on one another.
Wow, 30 seconds. That was awesome. Jenny, how's everything? Good.
One more today.
I think I'm good to go. I'm gonna go home in a second after this day. I know, it does. It feels really nice in here.
It's more than you're gonna up there.
My stomach hurts though. I think I ate something. Who? Oh, yeah. We get it.
No, we're gonna make a website.
We're making a website? Oh yeah, that's what you were saying.
So Mike, man,
Coupling.
nice job.
Yeah, that was cool. I need to head out. My stomach is like really upset.
Okay. It's almost noon, anyways. So it's a pretty good time. Let's talk for a sec about what I've been talking about. Are you clear on generics? No? Okay. So let's sit down together during lunch and talk about generics. Okay? So do we have a better idea of why generics? Lindsay and Mike.
Yeah.
For sure.
Would it increase the cohesion of your code?
What are you reading right now? Tell me.
He's not.
That's correct.
Tell me you're reading.
He's not.
I'm not. I did research yesterday.
Oh, nice.
Came across both those terms.
Yes. Minimize coupling, maximize cohesion.
Yeah. It was talking about dependency erection and spread and how that will
Maximize cookies.
lower
Cohesion.
Cohesion.
minimize coupling, which is minimizing the dependencies from object A to object B, or class A to class B, rather. Okay? All right, your homework. I need a second to type it up, but I already know what I'm going to tell you, so just give me a minute, I'll type it up, and then we'll go over it. Cool? Yeah, we are. Heck yeah, we're building a webpage. God. Just kidding. Not just kidding about building a webpage. We're totally doing that. Just kidding about the attitude.
Napoleon Dynamite reference?
Yes. All right. We're done with streaming for today. Goodbye, adoring fans. Peace out.